Hello. Today I want to work on some file system related stuff in Swift, and I picked something that's pretty simple so that I can do it on camera. So the thing I want to work on today is file permissions. As you may already know, everything in Unix is represented by a file. So your any of your hardware device, your network socket, anything is basically represented via this file-like interface at least. And for files, they each have a permission. Let's start by making a sample file. Let's say this in the temporary file. If we just run ls-a, well, dash l, I guess, most of you probably have seen this, which is within the list of information ls give us, there's the first of all is the permission. So bear with me if you already know all that. So each file will have three groups of permissions, and each group has 3 bits, for the lack of better words, read, write, and execution. So for example, the way we read this permission field is that ignore the first part for now, and we'll get to it later. For the owner of this file, so each file will have an owner, and it also belongs to a group. For the owner of this file, the permission granted is read and write, and a dash means absent of permission. This is for the users within the group for the file. So within this whale group, you can see only read is permitted. And then this is for the rest of the users on this machine, and only read is permitted. So we can add some more permissions here by doing this. Right? So now this plus X syntax means add X permission, and X means execution, right? So now you can see for the current user, you can read, write, and execute this file. And for the rest of the people, you can do X execution. And the in the C programming, in the implementation of the system, this field is represented by a number, not surprisingly, like everything in C, right? And the number, you can think of it as a number, an integer in octo representation. So the way this works is each of this group is represented by one octo digit. Read, write, and execution is each represented by an octo number. I believe execution is the number represented by the number 1. Write is the number 2, and read is number 4. So 1, 2, 4. You can think of it as like a bit in a bit field as well, but the interface that we've been using here actually has an alternative. For example, I can do the same thing by specifying 0 for this odd beginning bit, and then if I want read, write, and permission, read, write, and execution, that's 1 plus 2 plus 4, which gives 7. And then for here, for example, we have execution, which is 1, and then read, which is 4. So this will be 5. And similarly for this is 5. But just for fun, let's make it read only for the rest of the user. So that's just 4, right? I hope that this example makes sense. But now if I look at the file again, you'll notice that it's 0 for the beginning bit, and then 1 plus 2 plus 4 for the user group, and then 1 plus 5 for the group, and only 4 read for the rest of the users. All right. So like I said in the beginning, a lot of people already know how this works. Another way to retrieve this information is to use the command stat. So if I run stat on this file without any arguments, you'll see a bunch of information listed, and among them is this permission field, right? The reason I want to introduce stat is because when you use system API, um, the stat is I guess the one you use the most. So stat exists as a Unix API as well, and it is the one we're going to use today. The problem I'm trying to solve today is in Swift you can call change mode and stat with the C APIs that's included in your POSIX. It's very easy already. But yeah, let's get into it. Now I'm going to basically do the same thing we did here in code with the C API in Swift. So let's start by create a storyboard. Okay. All right. So the first thing we need to do is, I guess, turn off auto execution. And we're going to import Darwin because we're on a Mac, and this gives us all the system calls. I guess the thing we can look at now is this stat function. We can start by looking at its manual. So there's this set of system calls. They're fstat, lstat, or just stat, and it takes a path and returns a struct that via a pointer, right? So if we look at the struct, you'll see it has a series of informations, including like the 3 timestamps you may have learned in college on system files, and a bunch of other numbers. And that's what we saw when we ran stat, right? This basically is the list, the content of that struct. And among this content is this mode T field. It's an inode progression mode, I guess. All right, so here's in the alternative version, this is a better name. So it's mode of file. This is really what we're dealing with today. So I want to call this stat function on our file, but the first step is to convert our path into a C string, which is super easy in Swift. All you need to do is do this, and in this block, you'll have a C string. Anyway, so with this, we can already call our stat function. But you'll notice it takes a second parameter, which is the mutable pointer for the stat struct. And we just look at the definition for the stat struct. It's either one of this one or the other one. Anyways, so we need to first allocate a struct. That's easy enough. Stat, by the way, stands for status. It gives us a status of a file, right? So we can do this, and this will give us the struct. Yep, we just passing the pointer here, and when we execute this function, you'll notice that the stat function returned 0. 0 signals success in Unix. So now we can look at stuff in the status, and the thing we're looking at obviously is this mode T. So all right, so execute it. You'll see this is a number of some sort. If we drill down to the definition, you'll notice it's of the type mode. And if you keep going, you'll notice that it's an alias to a Darwin type. And if you drill down that, you'll notice it's actually secretly an unsigned integer with 16 bits. I guess we should go back to the manual and dig for more information, because what we want to read from stat is the permissions, right? Right. So here's some more information about st mode. You'll notice that it has a bunch of information in the higher bits. For example, whether your file is a regular file, whether it's a special block file, which I believe represents like a device, or whether it's a socket, whether it's a symbolic link. So already these are very useful information. And down here, you'll notice whether the read and write and execution search permissions for owners, right? So this bit in particular. But you'll notice that it has a reference to, actually it asks us to look at change mode. So let's just go there. So if we go here, you'll see a very detailed a bunch of symbols that predefined in the operating system, and these are the bits, the octal bits, if you will, that we should be looking at to to check whether the permissions the bits represents. Let's say I want to find out whether this is executable for group. If I remember correctly, it is, right? We made it, so it's 754. So all I need to do here is do a bitwise add with this bit and see the result. You'll notice it's not 0. And if we look at the same thing for others, execution for others with this symbol here, I believe now that should be 0 because the last group permission is 4. So 4 is read only. So basically, without any wrappers, this is the interface you'll be using to find out about a permission of a file. As you can see, it's pretty concise. It's pretty nice. Like it's the same experience of using C APIs. This is the strength of Swift, but also, the API is not really Swifty. So I guess finally I can introduce the thing I'm working on today, which is make this Swifty. Right, make this Swifty. Let's, I guess, start by making this type more safe, this mode T thing. I'm going to wrap it in a struct, and it is representing the file mode, right? But obviously it's a bit field, so the most natural thing to do is to make it an option set. And when we do this, the compiler will help us with the option set interface. Since we know underneath the backing field is a number, so we can use that directly. And obviously we all need to store it, so alright, so with this already we can improve the interface a little bit. So we can go down here and say we want to convert this file mode into our value, into our strong type, right? Now, since it's a option set, we can use its interface to get the binary answer we want, which is we convert the bits we want to use the provided in the standard library, use this free functionalities we get from option set. And you'll see we now, instead of dealing with 0 or non-zero, we can have Boolean results. And that is already very nice. And the next natural step is obviously, I guess I should mention, one of the goals for my design is that if you already know the system API, it should come natural to you how the higher level wrapper interact with the existing API, right? For example, if you know Swift, then this should if you should be able to guess this without much trouble. Okay, so the next step is we want to make it more friendly to use, make this API more friendly to use. What I mean by that is you shouldn't know about this opaque symbols, right? By the way, the symbol has certain pattern in it. This I means inode, and then X means execution, and GRP stands for group. So if you look at some of these other ones, I guess from here, you'll notice for example, this is execution for user, and this is write for user, read for user, and then RWX, so all three for user, right? So these names, if you know them, it's a reasonable enough API. It's just not very modern and very C-like. So what I really want is something like this. Let's use this as an example. This would be execution for group, right? So group execute. Hopefully we'll get something like this, ix group. And instead of creating these raw values on the fly, you can just say group execute. Basically, you say, does this file mode uh, permits group execution, execution for users in the group, right? So this is the next step we're going to do. And we're going to do that with a better editor than Xcode, I guess. Because we already have this existing definition, and we know where the source file is, hopefully. File mode content, right? So here we can just paste in this stuff and clean it up a little bit. We will never need the actual values because that's predefined. We want something like this. In this case is user, but we'll leave that for now. Equals value. Make this away. Alright, so now like this. I guess we're missing part of the manual here because we only have one of these. I think we have 3 in total. So we're missing the last 2 here. Do the same thing to these guys. Go. Alright, so this obviously is not valid Swift because we don't have names. But that's easy enough, right? For these are for the users. These are for the group. These are for others. These each has their own name. So let's just do the name here. So set user ID on execution. Verbosity is a virtue here. Set group ID on execution. Save swapped text even after use. So for read write execution mask, we can just say name it all, right? And then for this is read write execute. Now this is where using editor with column editing really shines, right? This is way faster than what it could have been. Now all of a sudden, right, our user interface dramatically improves. So here, after I get a permission, I guess we already demoed this, but now it's really complete, right? I can look at, does their file permits user write? Right? Immediately I can look at it. So far we've been just reading the file mode, but with this file mode, it also becomes super friendly to just change the file mode. So this is, I guess, what I meant to do. We can use the literal syntax provided by conforming to option set, right? We can do this and then just say new mode dot raw value. Yeah. So not only can we read in a very ergonomical way, we can also write the new permissions this way. Okay, so let's improve this even better because this still requires you to interact with the stacked system call, right? So for now, I'll just write a little function that wraps that part for us. This is a repeat of what we have here, basically. So we'll write a status, we'll get a status, we'll get the C representation of the file path, and then we'll read it, and then we'll return the result. We'll copy this. Right. Okay, so down here, instead of doing all that, now I can simply say mode for TMP contains user read. Boom. This is contrast this with this, right? This is way more usable. Obviously, this is just the first step. of a larger effort because we are still representing the path with string, and given that we wrapped an integer here, we should do the same thing over there as well. Anyways, okay, so to make it friendly to users who are familiar with the raw digit representation of the permission, we can make this better by extending the file mode type to conform to expressible by integer literal. So for expressible by integer literal, all we need to do is implement this, which we'll do here. Okay. Now, in addition to creating the mode like this, you can do, let's attempt to recreate this, right? You can say this is actually 0, what was it? All read. So 00744, right? And this would give us the exact same thing here. So that's pretty nice. I guess the last thing I want to do is basically mirror this read with the write API. So we can have a set file mode function, and it will return the file mode after it's being set, or something like that. One thing we haven't done here is doing error handling. Hopefully this stuff should all throw, and we'll look at the return value of the system call and throw errors accordingly. But for now though, let's just wrap up by doing pass dot with C string. I guess we just forward this to change mode. And we return the new mode by just calling the function written before. In addition to calling change mode, you can say set mode. I wonder if you can do this as well. For right. Let's see, does it contain group read, group write? It should be false, right? Yeah, so we've gone from using this pure C API to this nice Swift API. Like I said, it's not complete because we're still using string to represent the path, but already, as you can see, it's friendly. It's friendly for users who are familiar with the old API, but also friendly for users who just don't want to learn all the low-level details. Anyways, that's all I want to do in this video. Thanks very much for watching. Bye.